Hello and welcome to Apologetics 101. I am your host, Brian, your resident Christian apologist, and we've been doing a Are We Apes series, a series that is focused on responding to the claims of alleged human evolution by evolutionists. And we're now coming on the very end of this series that I had started a while back. And so series is starting to end, and I got with you today Dr. Jerry Bergman, and this is going to be it's going to be like kind of like a two-part ending to the series. Part one is going to have Dr. Jerry Bergman. Part two is going to have Brian Thomas. As long as everything works okay for that interview, that will be next week, and not this coming week, but the week after that. I've got an interview scheduled for Brian Thomas to come on my channel, and we're going to also be discussing the same topic matter, but from a different scientist reviewing this particular situation. I thought Dr. Jerry Bergman did an excellent job, but I'd already kind of double booked because I didn't hear from Brian Thomas when I originally sent out the email. Reached out to Dr. Jerry Bergman. He responded, and then Brian Thomas eventually responded again after later. But I decided to just do kind of like a two-parter episode, just to kind of get two different perspectives on the differences, anatomical differences. And it'll be kind of good, cool to split the last episode of RE8 series into kind of like two parts. So it's a two-parter, with the first part being with Dr. Jerry Bergman on it. Hopefully everything goes good with the second part, and I will have Brian Thomas on for that one, and that will mark the end of the All We Apes series. So this is getting close to the end. I am ending the series because I have already started a mini series called the Tompkins Controversy Revisited mini series, and I want to continue that and finish that up and respond to one Erica from Guts and Gibbon. And so I can't wait to do that. And I've got some more series planned up as well. So lots and lots of content. But I hope you enjoyed today. I thought Dr. Jerry Bergman did a great job at the interview. We covered a lot of ground. And so I can't wait. And so without further ado, let's dive in.
Hello, my gentle and, of course, very modern apes.
Here, I'd like to kiss you goodbye.
All right, but you're so ugly.
Human beings are not just related to apes, but actually aren't.
This is a primate. And so is this. And so is this. And so is this. Hey, that's me.
We are still hominids. We're still primates, mammals, tetrapods.
Well, hello, and welcome to Apologetics 101. I'm your host, Brian, and today my guest is Dr. Jerry Bergman, who's been on my channel many times and recently had a debate with Erica from Guts and Gibbon that we did a review on not too long ago. How you doing today, Dr. Bergman?
I'm doing pretty good.
All right. Do you want to
Been
give
busy
like a...
doing papers on this issue.
Oh, really? Um,
Good.
Could you do a brief introduction to yourself? I know that most people are aware of who you are, but just kind of give a brief bio there, and we'll move on into our Q&A. Or our wait, you got a presentation, don't you?
Yeah, I can cover a
All
few
right.
things.
Well, go ahead and do your
Well,
introduction, and we'll move into it. Or into
my name's Jerry Bergman, and I've been involved in this issue for 40, 50 years. been teaching at the college level for 40 years, taught science primarily, as well as some psychology courses. I taught at Bowling Green State University, University of Toledo, the Medical College of Ohio, and other schools. So a lot of experience with students and a lot of experience with this issue. Although in teaching at the college level, of course, you have to be very careful that you are very tactful in presenting the whole creation worldview. And it's there, but you have to be somewhat hidden because of our laws, which really ideally we need to be able to freely talk about these issues, but unfortunately that's not reality. And so therefore we are somewhat limited in being able to cover this issue. I liken it to basically that talking about worldviews, evolution's a worldview, creation's a worldview. Worldview tells us where we came from, why we're here, and where we're going. Evolution says where we came from, we evolved. Why are we here to survive? Where are we going? When we die, we die. Creation says, why are we here? God created us. What's our purpose? Why be here? To serve our creator and our fellow man. And what's the afterlife? Well, the afterlife is we merit God's blessing. We will spend eternity with our creator. And so it's basically, they try to picture this as creation versus evolution. And that's a distortion because evolution is a worldview, as I just mentioned. Creation's a worldview, as I just mentioned. And that is a major issue we have to contend with, that is distorted. My view is religious, you say. Your view is science. Therefore, you can present your view in the schools, no problem. I can't present my view in the schools because mine is labeled religion. And it's a problem labeling worldviews a religious or science worldview. And of course, in fact, both creation and evolution are religious and science worldviews. Several papers I'm doing, I'm writing a book on whales, and the several quotes, in fact, I think I have one. These are one of the best evidence we have of evolution, macroevolution, whales. And when you go through the evidence, basically we start out with Pakicetus, which is a dog-like, it looks like a dog evolves into a whale. The same thing with human evolution. Of course, humans, we tend to look at not a long-term back ancestor, but we tend to look at our recent common ancestor, which is our primates. And if you think about it, primate changing into basically that happens by the process of mutation. A monkey-like creature, actually a common ancestor. And if you think about it, that is somewhat delusional, I guess the best way of describing it. And more as I work in this field, think about it, in many ways, evolution is a delusion. It's a delusional idea. Another example is where did birds come from? Well, they evolved from dinosaurs. So you start with a dinosaur and you end up with, through evolutionary steps, a bird. And that is really somewhat irrational, as is a dog evolving into a whale. And therefore, in many ways, evolution is somewhat, and if you think about it, in history, we've had so many irrational events. For example, Germany really thought, little Germany, about the size of Montana, that Germany could take over the world. And of course, they were starting a small part at a time. And actually, they did probably better than most people would have thought. But on the other hand, in the end, there's no way. And Hitler's
Jerry?
Germany declared war against the United States as well. And so in many ways, it's delusional. I have some slides here which we could look at. Let me see if I can get those up,
I already got the thing.
which outlines this.
Yeah, I already got it set up so you can share your screen.
Okay, you're ahead of the game. So I guess there's so much frustration in trying to present information because so much of what I present is really unequivocal. And one of many examples is I was just reading a book by Michael Shermer called Science Friction, and he talks about the evidence for evolution, and he pulls out the old canard of backwards retina is backwards, and that has been discussed by many, many people. Me, I've got at least 5 articles on that. And yet he brings that up again as if, well, that's proof we evolved because God would not create us with a backward retina. And if it was the other way, it would work fine. And so it's to some degree, it's frustrating, but I think my guess is your audience is probably more enlightened than most. Now, let me see if we can get this going. Slideshow. Okay, try to review some of this. What's evolution? Well, we start out with basically bacteria, and we end up with people. And pictorial illustrations help illustrate the difference between humans and apes. And this is a good example, illustrating the difference of humans right here and apes. And of course, the question is, how do you go from a human to an ape? Well, the answer is, and of course, Darwin was confronted with the same question. He had no idea. He just felt there was a huge amount of variation, which is true, but there's not enough variation to go from a human to an ape. And what's the explanation today? The explanation today is by mutation. And as I'll talk about in a few seconds, I worked in the area of mutations at the medical school, and we know a lot about mutations because mutations cause disease. In fact, we know a huge amount. So many of us have spent our lifetime studying mutations. And we know there is no way he's from an ape to a human. Can't happen but with mutations. Why? Because for a number of reasons. The main one is that most mutations are not beneficial. They're problematic. Okay, let's see if I can get the next. I don't want to go. Okay, there we go. And looking at the past, and of course, one way of evaluating the efficacy of evolution is what was believed in the past. And this is from Scientific American. And they start out with Java Man, Piltdown Man, Neanderthals, and Cro-Magnon. And now all of these so-called links have been thrown out of the fossil claims. I may have to get some water in a minute. And Java Man has been shown as problematic. And debate actually still is what that is. Piltdown Man is clearly a fraud, no debate there. A Neanderthal are clearly one of us, no debate there. Cro-Magnon are clearly one of us, no debate there. And so what we have is, wants to go the other way. Piltdown Man, it's a fraud. And again, no debate. Java Man, that's all the evidence we had. And this is a problem in evolution, is that we have often scant evidence, especially human evolution, which of course is one of the main focuses of the evolutionary community. They're not so concerned about the evolution of clams or many creatures, but they are concerned about the evolution of humans. And there is Neanderthal Man, all dressed up and nowhere to go. This is a display actually in the area of Germany where Neanderthal was discovered. And this is now a modern example of producing what they actually look like. What they look like is actually we've done pretty well. When I taught forensics, you can find a skull, and the skull may not be in very good shape. And we've developed the techniques to the point where you can actually build a face onto the skull. And in the one case I show my class, that the face they built was so accurate that somebody recognized. Of course, the first problem was, who is this person? So a girl, they figured that out, a young woman, and they put the face on there. That was shown on TV, and a woman called and said, that was mine. A woman lived next door, and she disappeared several years ago. But I swear that is the woman who lived next door. Turned out it was the woman that lived next door. Turned out to be murdered by her husband, and he was convicted on the basis of the assembly of the face on the skull that they found. So that science is really doing well, but of course you've got the basis for it. And this is an example of producing a girl on the basis of the shell. It's Paralpithecus, an embarrassment in evolution, because turned out to be the tooth of a pig, precarious actually, and not humans. Although teeth were similar, and therefore it's not all that amazing that they would be mistaken. And there is Cro-Magnon, and right now, could be you. Cro-Magnon skulls look just like our own. A little bit different. They had a little bit different traits, but by and large, people group. And the name calling is very, very common in this area. If you have evidence against what I'm saying, present it. But all too often when I do debates, in fact, often when I do debates with evolutionists, they don't have the evidence. They can't defend themselves adequately. And so therefore they resort to name calling. And this was an example during the Scopes trial. They basically name called against the people who presented the evidence against the creation worldview, and or just didn't believe in the creation. Just didn't believe in the evolutionary worldview. And their response was to make fun of them. Down with education, to hell with truth. And of course, back then the evidence was what? Well, the evidence was, now we know, simply all overturned. And so they were making fun of us, and it turns out the science supported us today. And a cartoon illustrates that. Tragically, we have all too often the churches support the evolutionary worldview because they feel that it is unequivocally shown to be correct. And one friend of mine at a conference we had a few years ago at Cedarville University, they basically did a survey of all the Christian colleges. And they found of the Christian colleges, all but about 12 accepted and taught the evolutionary worldview. Where did men come from? He evolved. The 12 did not accept that worldview and did not teach that worldview in their classes. And to me, that's horrendous when the delusion is so great that indeed the Christian colleges, by and large, with few exceptions, have gone along with that worldview. The book that I did, I and Peter Line and Jeffrey Tompkins and Daniel Biddle did, Apes as Ancestors, and we show unequivocally the evidence is very, very clear that indeed all the claimed evolutionary ancestors have been found to be invalid. How do we do that? Well, basically what we did was we looked at the claims made by paleontologists, and then we looked at the evaluation of those claims by other paleontologists. And we found paleontologists have effectively refuted other paleontologists' ideas. So in essence, evolution has been refuted by the paleontologists at large. Now they still believe in evolution. They believe evolution occurred. And therefore they argue, well, my theory is correct. You turn around, you say, wait a minute, my theory is correct, your theory is wrong, and what you have to say is wrong. And so they criticize each other, and that's the basic evidence that we use to argue for our worldview. This is called the forward-looking picture of humans, and basically because we progress from, in this case, a Pilopithecus all the way up to Ramapithecus, and actually, of course, man, they call this the progression. And again, all of these fossils have been evaluated. The evidence for these pictures, like Drawopithecus, has been evaluated by paleontologists themselves. And by and large, every one of these links have been disproved by evolutionists themselves. Now, they still believe in it. They just have other ideas. And when we compare these skeletons, you look at differences, huge differences. it doesn't take much skill in anatomy or, in this case, bone science to realize that there's a huge difference between apes and humans from the skeletal level. And as we go in differences. Now, it's true some bones are similar. Some bones, the difference, of course, is between the hip bones, enormous difference there, between the feet and the hands. So there are many, many differences. And you can see in the description now of these differences. Okay. So we share similar bones. I say the same, but that's not quite correct. The shapes and sizes, though, of difference are differ. But of course, in general, they're about 98% or so the same. But the differences can be discerned if you're a trained paleontologist. So there are differences there. And humans are adapted for bipedalism. And of course, apes are not. Chimps and other primates are not. And the foramen magnum, of course, is one major difference between the two that is indicative of a difference. Of course, the main differences, which I don't even get into, are differences in the mind, in the brain, that there's so much that humans can do that no ape can do. Apes have a lot of talents. They can memorize certain things, but they're very limited to in comparison with humans. And these are pictures. That's the skull. And they gave that skull to 4 different artists and taken this skull. Now, you can see this skull is made out of lots of different fragments. And so it has to be assembled according to the judgments of the person who assembled it. And so, given that skull, they had 4 different artists draw what that would look like when we put flesh on it. And you can see we have 4 different pictures. And this was done by National Geographic. And this was Zinjanthropus boisei is the one they use. Okay, another example is these bones were given to an artist. And you can see the bones at the top. And all too often, when we look at human evolution especially, we have bone fragments. There's only a couple of examples of skeletons that are fairly complete. But the vast majority, 99%, are fragments. And from those fragments, this was again done by National Geographic, and they did a good job on this, doing this survey. And from those fragments, the 4 pictures you can see there were drawn from those fragments. So you can see that there's an enormous amount of artistic evidence that is part of the ability to come up with a drawing. Oh, one thing they did know, this was a female. That's all they told him, was a female. And so they drew the person, which may look somewhat like a female. Now, when we look at evolution themselves, what do we find? Well, this is Richard Leakey's model. And he's, of course, one of the most eminent paleoanthropologists ever. Bernard Wood, another eminent paleontologist, he has a whole different model. Okay. And Don Johnson and Tim White, a different model. And Colin Groves, a different model. So we have a huge amount of disagreement in the paleontological community. And that enormous amount of disagreement is illustrated here in these 4 drawings. And now there's obviously a lot of agreement. The main agreement is we evolved, period. That's the main agreement. The details is a very controversial area. And that's why they... Okay, there are thousands, possibly tens of thousands of bones that they use to defend the ape to human transitional stages. And then again, the most common progression, here we go. And again, most of these have been disproven. Well, they've all been disproven in the end. And this is a simplistic picture, but yet the progression is by far one of the most commonly used illustrations to present human evolution. It also is one of by far the most effective, and therefore it's been very effective in convincing people of human evolution. Okay. And I have several quotes here, but you can see that the leading paleontologists say that this is not it's not true. It has been largely refuted that progression is not true. And one way of showing that is when we line up, look at all the skulls that we found, and try to get a progression, what do we get? We get a lot of variety, a huge amount of variety. And as we get more and more finds, we then do more and more comparisons, and we realize this simple progression is not valid. And that's true, of course, with so many things in life. Humans, if you took 1,000 skeletons, you'd find many, many differences, minor and the humans differences. And then again, we're trying to put all these together. And this is one effort we have to put them together. And we assemble these in somewhat a pattern, still working on it. And there we go. We're working on it more. And what do we find? We see, and there we go. There's 4 different groups. So what do we have? A progression? No. We've got a bunch of the Homo group, the Paranthropus group, the Australopithecus group, and Ardipithecus group. And probably there's a few more groups. But what we have now is not evolution. We simply have a group of creatures which are clearly grouped together, but which have a large amount within them variations. And of course, we see that with humans. Look at all the variation we have in humans. We have so much variation that they claim, I don't know if this is true, but they claim there's no 2 faces in the whole world that are identical, exactly identical, period. No 2 faces, some close. And humans will judge them. Yeah, these 2 faces look very, very similar. To me, they look identical. But when we analyze them in more detail, we find that the variety in humans is so great that indeed we have what's the number of people we have now? We have 8 billion people, and yet none of them look exactly like any other person. And there's regression again. And again, that's everywhere, but that is now not true. In fact, a lot of evolutionists have basically said this is really dishonest, and we need to point out this is not true. Okay. There's various means of locomotion: knuckle walking, bipedalism, bipedal behavior, and bipedal walking, meaning, to summarize what this is referring to, that some apes can walk bipedally, not too bad, for a short distance. The normal locomotion is not bipedal, it's quadrupedal. It's 2 hands and 2 feet. Actually, what apes have is not 2 hands and 2 feet. What they have is 4 feet. Okay? And so these differences are there, but they try to look at those differences and say, well, chimps can walk bipedally for a short distance. Therefore, there's evidence that they are on the way to evolving into modern bipedal locomotion. Or that's going back to many thousands of years ago, chimps had some ability to walk bipedally, and eventually they ended up being able to evolve to humans that can walk very comfortably. Used is this headline, what it means to be 98% chimpanzee, and that was the claim for many years. Now I think it's closer to 85, and I can't say I know for sure which difference it is. I do know for sure that it's very difficult to compare genes in humans and any other creature because there are so many differences. So much of it is not comparable. Now we have many genes that are comparable, but so many genes are simply not, they are not comparable. How do you compare things that are essentially uncomparable? Well, it's hard, very difficult. And so therefore they guess, actually many comparisons were made on the genes that were very comparable. But even those that were very comparable, there are still differences. Yeah, in many they found. And the latest study is 85.1% similarity, a published article in Nature. And again, this is an enormous difference, huge difference. But on the other hand, there's still, even about this data, which looks pretty good to most people who have background genetics, there are so many who claim that, well, there's a problem with it. And if you analyze the data carefully, yeah, you'll see certain things that are not quite right. My guess is they did not compare the entire genome, including the X and the Y, with chimps and humans. They didn't compare the whole thing for chimps and humans. They compared a lot of it. I understand they didn't compare the X and the Y for several reasons. But at any rate, part of the problem is that evolutionists wear these evolution glasses, and the evolution glasses distort the world, and they see the world the way they want to, and they see the world as evolutionary, and they therefore look at evidence that supports that worldview. And that's a big problem for a number of reasons. I'm doing an article for several reasons on bees, and there's huge problems in trying to figure out how bees evolve. For example, bees have to have flowers. Without flowers, bees can't survive. They've got to get the nectar, they live off the nectar, and flowers have to have bees. So how do flowers reproduce without the bees? And so you get a problem. What evolved first, the bees or the flowers? And it's debated. What they conclude is that they must have evolved pretty much simultaneously in order for bees to survive and flowers to survive. And I thought that's ridiculous, because it must simultaneously. What is which the bee was able to, that had enough the skills and ability necessary to gather nectar from a flower. They can't imagine these things, but they basically say, well, we know it's true because evolution's true. And okay, this 86%, 85%, about 15% of 3 billion, which would be about 450 million differences between apes and humans. And that's a lot of differences. So therefore, you have to have enough mutations in the original chimp kind, the common ancestor. You have to have enough mutations to get 450 million positive mutations to evolve one into the other. And the problem is, very simply, vast majority mutations are harmful. And that's the work that I did for many years at the medical school. We know that they're harmful. We know why they're harmful. We know why you're not going to get beneficial effects from mutations, except in rare cases. You'll get a few. The main mutations that cause beneficial effects are the mutations which break a gene and allow another gene to function. And so that's really not improving. It's not producing a better gene. It's basically getting one out of the way so another gene can function. And if I would have mentioned at the medical school that, well, gee, I wonder if there's some mutations that are positive, they'd probably look at me and say, are you okay? You've been working too hard, been spending too much time thinking about mutations, because the idea that there's mutations that are positive, and of course there are a few rare ones, but by and large, the vast majority are what they call near neutral. Near neutral means they're not directly beneficial and they don't cause any harm, but they add up. And so near neutral means that as time goes on, you get more and more of these near neutral mutations, and you end up with genetic catastrophe. And of course, the best example of that is your car. You start out with your car, and it's a little rust here. You get brake pads get worn out, tires get bad. A lot of these changes, you can still drive, but after a while, you have so many problems that eventually you can't drive. And this is a good example of that. Methinks it's like a weasel. This is done by Richard Dawkins. And this is how he explained evolution works. This is how he explained it. So basically, you start with gobbledygook, and the goal is to get methinks it is like a weasel. That's the goal. So you start with W there, and mutations occur until you get what you're looking for, which is M, and then that's retained. That's selected. E, you get an E here, so that's retained. So after 44 changes, you end up with me thinks it's like a weasel. The problem with that is, and I mention this to students and they right away caught the problem. The problem is the computer program is specifically programmed to select the goal. And you can't even compare that with human evolution because we're not programmed to select certain advantages, certain genes. Another problem is, and this is a huge problem, is hotspots. We find in genes that the vast majority, and I can't say how many, but the ones we looked at quite a few, but there are billions of genes out there, so we have, lots more, but over and over we see hotspots. Hotspots means that the mutation occurs in the same area. And this is P53, which is a very, very important gene because P53, when that's damaged, it doesn't work anymore. And as a result, cancer is allowed to get through. And so that's an important gene. And we can see that there's primarily 3, maybe 5 hotspots. And you see that over and over. And so how are you going to get, me thinks just like a weasel, how are you going to get any beneficial changes when the mistakes occur over and over in the same areas? And there are many, actually better examples, but P53 is important because we know that that's a high number of people of cancer. About over half of all people of cancer end up with P53 damage. And here's E. coli gene. Now that is probably more typical, but where are all the mutations? That number 199, that's where 90% of the mutations occur. You get a few in other areas, but almost all occur in one area. And here's another example of hotspots. So with cancer especially, we've determined there are many, many hotspots. And that's why you don't get improvements. You invariably get cancer or you invariably get damage. And that, I think that's lethal to evolution. One study, they found 2 mutations accounted for 94% of all mutations out of 319 they identified. So of the 319, 94% were of mutations. Another problem is, conversion to thymine. We can see 58% of the conversions, the base pair conversion, only 14% are to guanine, 23% to cytosine, and 5% to adenine. What that means is that a thymine base pair is going to load up. And that again is what causes deterioration of the genome. And that's why you do not end up with improvements, you end up with deterioration. And deterioration tends to go in one direction. And that's important to know when you're looking at cancer. And also, it's not just the amino acids that's important, but the charge is very important. That nonpolar uncharged is critical for the amino acids to form proteins, to fold to form proteins. Protein folding is critical. Without the proper protein folding, we end up with a big problem. We end up with damage and it doesn't work. The proteins don't work. The proteins have to work. To work, they have to fold properly. To fold properly, they have to have in the proper places, nonpolar, uncharged, polar, uncharged, borderline polar, nonpolar, polar positively charged, and polar negatively charged. So the charge is actually what produces the folded protein. It produces a 3-dimensional conformation, which is critical in proteins working. And so when that charge changes, basically what you have is mutation doesn't work, protein doesn't fold. And so the evolution account is valid if you make one change. In fact, it's very hard to come up with any change that's beneficial. In this case, no matter what letter you change, now there's a few exceptions, but no matter what letter you change, you're going to find some that are invalid. Okay, moving on. Another important thing is that when you have one mutation in one protein, it has effects, or could have effects, in the entire system. And this is called the interactome. And what we've done is we've looked at the entire interactome, and we find that, for example, this one right here, if you can see it, this one right here, this interacts with hundreds of other proteins and genes. And so therefore, when you have a few changes, it messes up the whole thing. Like a car, if you have a few changes, the whole car doesn't run. It may still run with some changes, but by and large, when so many of these proteins are changed, then you end up with messing up the whole system. It doesn't work anymore because it's all interrelated and all the functions have to work in order for in this case, the person to live. Lethal problems, prokaryote to eukaryote, no idea how that evolved. The claim is endosymbiosis, but that's lethal. That explanation does not work. And so how do you get eukaryotes? You can. Evolution of sex. That was a great mystery that Darwin talked about. How do you get sex? You have to have reproduction. Otherwise, of course, the males and females in order to function to produce the next generation. So therefore, they recognize evolution of sex is a big problem. Give you get some water here. Evolution of life. There are horses, humans, and whales. And I've done a lot of work. Examples that they claim are the best examples of evolution. All of them have failed. So therefore, the evidence for evolution is overwhelming. The thing here. And this is an excellent book, which is long. It's about, 350 pages. But this book shows that there's no way, and they've not been able to come up with any viable explanation to explain the evolution of sex. And my book here, Fossil Forensics, which is now out in a new edition, I basically show that indeed all the animal categories we've looked at, insects, amphibians, primates, there is no evidence, no good evidence for evolution of any of these. So evolution fails. There's the old example of the evolution of the horse. And what we found is these claims have all been refuted. And a good paleontologist, several have looked at this carefully, and they conclude we do not have any good evidence of the evolution of the horse. And these drawings here are fraudulent. This is the claim they use. There you go. And it looks like evolution occurring here. But with the horse especially, we know there's an enormous amount of variety. And these charts they draw, which tries to show the evolution of horses. Another example. And Darwin was wrong, according to this New Science magazine. And of course, they're saying Darwin was wrong, but evolution is still right. Evolution is still true. And so they're not trying to say evolution's wrong. They're trying to say Darwin's theory of evolution was wrong. And okay. Questions, comments? I find students about 40 minutes and they're overwhelmed with information. So that's why discussion is very good. So comments?
All right, thank you for that presentation. I appreciate it. Oh, by the way, on the X and Y chromosomes, they did actually have a study on that. If you want me to, I can send it to you. But they found it was like the at the Y chromosome between humans and chimps. They did this was after they fully sequenced the chimp Y, not the whole chimp genome, but the chimp Y and the chimp X chromosomes, and they found the Y chromosome to be like 26% similar between humans and chimps. So it's
Oh,
extremely
okay.
low. But yeah,
Yeah.
I can send you that study if you want to. It was in
Yeah,
Nature.
please do.
Also, with the differences on that, as you know, that there is an actual study that they did recently after the ape genome was fully sequenced, and then they found out that there was like 12.5% to 26.3% differences between six different ape genomes, including chimpanzees, and the fully sequenced human genome, T2T. And so I thought that was interesting that they found all those differences, which actually I have a question on those differences too.
Sure.
But we'll get into all that. All right. So what would okay in terms of anatomical differences, um what would be the most prominent difference do you think that humans and chimpanzees have that they're different from each other. They're just like fundamentally distinct between humans and chimpanzees.
Yeah, the main difference would be, of course, the brain by far, the ability to talk by far. The apes, there's no way you can get them to squeak so they sound not too bad. Of course, you can do a better job with birds. Actually, you can get birds to talk pretty fluently, but the language, so language is a major issue. And of course, bipedalism versus quadrupedalism is enormous difference. And so those differences alone are enormous. Probably many areas, like many organs, the hearts are fairly similar, so many organs are very similar, but the major differences are the brain, language, and the means of locomotion. So those are huge differences, which they haven't been able to bridge, partially because there's such a difference in those areas between us and our closest so-called ancestor.
As we mentioned in our
And
debate review of the debate that you did with Erica, there's actually a lot of different things that actually go into human locomotion in terms of bipedalism. So it's not just simply one particular thing or another. It's literally the whole package deal of all these different things. And so that actually creates even more differences when we start looking at chimps and humans and realize that humans are made to walk upright, and that's why our feet are made a certain way. It's why our hips are made a certain way. We're made for bipedal motion, whereas chimpanzees are not designed to walk like us. So there's all sorts of different components there that indicate that they are designed to walk uh, on their knuckles for the most part. I mean, they can walk a little bit upright, like you mentioned earlier. They can actually do that over a short distance. Um, but even then, it's not quite like us because we are literally designed a certain way that we can actually walk the way we walk and move the way we move, whereas chimpanzees are not designed to do that. They're primarily designed as an arboreal creature that they're a tree dweller and being able to walk on the knuckles and things like that. And so you start seeing differences like in our phalanges are different from chimps. Their fingers are longer, their arms are longer, they're designed to swing from trees. Um, you mentioned the their feet. You said that they had 4 feet. I don't know if you mean did you mean that because they walk on all fours, or did you really mean they have 4 hands?
oh yeah, that's a good point because in some ways they have 4 feet, in other ways they have 4 hands. It depends on how you look at it. We have hands designed clearly for different behavior than we have feet. So they're clearly designed to be very different. But yeah, that's a good, I'm glad you brought that up. But chimps have basically 4 hands to climb trees. So in many ways they have 4 feet and four hands. So that's a good way of putting it, which is so very different from us.
Right.
And we would have a very hard time walking on our hands and our feet. That'd be very difficult.
Another thing I sometimes notice is also the fact that even though there are people that obviously like climbing trees, we still struggle with it because our bodies are not made that way. Our feet are not really made to grab hold of branches and things like that, the way apes and chimps and things like that, and other kinds of apes are designed to do. And so we struggle with it when we're trying to climb trees because our feet are just not made for that. Whereas theirs is. And I think, would you say they're partial bipedalism, the way like Peter Line would define them as optionally bipedal. Would you say they're partial the walking upright helps them when they're in trees to walk on branches and that sort of thing? Is that
Yeah, they are
basically
partially on that.
go
That's
go
true.
ahead.
It's a good point. They are partially bipedal for a lot of reasons, but not nearly, of course, as effective as we are. I have had a torn meniscus, so I've been not doing too well lately because which is not an uncommon issue, but a torn meniscus. And boy, I can't walk as well as I used to. It really has affected me, even though the only thing that's different is that meniscus, the sheath between the bones is torn, and therefore other changes occur, and therefore I don't walk as good as I used to. So you realize how important all these things are to be able to walk on 4 feet.
Right. Um, you mentioned the pelvis area. How different would the pelvis be from chimps and humans and apes and humans that differ? Obviously, ours is differ significantly to the point where we're actually capable of walking upright. Um, what would your assessment be on because I know you specialize in anatomy. What would be your um, comparative analysis of that between chimps and humans? How different is that in the pelvic area?
Oh, it's enormously different. The pelvis of humans is wider and longer, and and I should explain that chimps is longer and thinner, and then humans it is not as nearly as long and it is a little bit wider. And interestingly, the hips bones are first thing in forensics. The first thing you do is you've got to determine is it an animal or a human? You determine that by the hip bones, or is it a male or a female? And that's also determined by the hip bones. So you get a lot of information, not just primate and not primate, or male or female. You get that information from the hip bones. And of course, there's other evidence as well, but the first thing, the easiest, is to look at the hip bones. And that's what they do when they find a skeleton. The first thing you do is look if the hips are there, if the hip bones are still there. So a lot of skeletons are they decay, and then animals carry off the parts, the body parts, or the skeleton is affected adversely in some way, and therefore they can't look at that. But that's the first thing they look at.
Would you say that
So
that's
they're pretty indicative.
would you say that that is affects our locomotion significantly compared to the way chimps walk and apes walk in general to the way humans walk? Do you say that's a big difference there in terms of locomotion?
Oh, it's colossal. It's colossal. Yeah. Colossal difference between effectively walking bipedally and effectively uh, walking on all four uh, extensions, all 4 feet or all four hands, however you want to
You mentioned
describe it.
you mentioned the fragment magnum, the framing magnum. Now my understanding is that apes do have like variations of it, but they're not quite like the way humans are designed. Now, of course, to walk upright, you need more than just a framing magnum, but obviously that is a difference, right? With chimps, their frame magnum is positioned a certain way that they're not quite like what bipedal is, where there's more like what you expect from a quadrupedal animal. Um, is that your assessment with the Fragment
Oh yeah,
Magnum?
that's one of the first things or the second things they look at is where the foramen magnum is relative to the skull. And so yeah, that's critical because for most primates, it's more towards the occipital area of the cranium, and therefore they look to see how close it is to the occipital area, the back, as compared to the neck area. And so, yeah, that's critical in finding out, because when apes walk, they have to look forward so they can see where they're going, and therefore that design has to be different so they can look forward as they're walking forward. Where humans, since we stand up straight, we look forward automatically because of the placement of the foramen magnum. So that's true. That's a big difference. Although there are a few primates that have foramen magnums which are a little bit closer to humans, but that's pretty clear way of determining whether the animal walked upright or was a primate that walked on all fours.
What are some differences between the
That makes sense.
morphology? Yeah. What are some of the differences between the morphology of the skulls between humans and chimps? Would you say that are significant, or apes in general?
Well, size, of course, is a major difference. So our brain capacity is probably 3 times on the average of most chimps and or most other primates. But of course, primates can be from the size of a dog to the size of a human, a gorilla. So you have an enormous difference in primates themselves. In fact, you have some primates that are almost the same size as a cat. And so therefore, there's a huge difference among primates, but a huge contrast between, of course, all primates, and humans. Therefore, that's a great difference.
We talked a little bit about the feet of apes. Now, that differs significantly because their feet is really just another set of hands, because they have
Right.
they don't have a inline big toe, they have a opposable big toe, so it kind of designed to grab hold of stuff like branches, which is very different from um, us, because we can't use our feet as in a set of hands. Although my wife has this skill where she likes to try to use her toes and stuff, but that's something else. But anyway,
Yeah.
but we don't have that capacity to be able to use our feet in that manner because we have an inline big toe. So would you say that there are significant differences there? Because I guess because of the way apes are designed versus the way humans are designed, we're not designed as arboreal creatures. We're not designed to walk and move in trees, but yet apes are. And so, would you say that that's something that you would expect from a creature that is designed to be able to climb trees and move along branches and things like that? Is that something that would aid that particular type of animal?
Oh, yeah, clearly. And that's why they can run up a tree like we can run up a hill. And so it's an enormous difference for arboreal life and trees. They've got to have that design difference in order to get around in trees. And of course, one place that apes and chimps especially hide is climbing trees. And there's a few people that are pretty good. They can climb trees, but 99% of us, there's no way we can even compare with a chimp. You put a race between humans and a chimp, and they're going to win 99.9% of the time. So there's no way we can climb up because we don't have the opposable thumb in our feet, whereas they do.
Some claim that our brains are more developed versions of ape brains. Um, Anatomically, is that true or not?
Well, I'd say more developed, I don't think is a proper term. The proper term is they're just designed differently. We have areas that they don't have at all, like speech areas, and we have a number of areas that they don't. As far as I know, Broca's area. There's 4 or 5 areas, as far as I know. Chimps don't have it all. So it's because they, even if you could train them to say the words, you still have to train them to use language, and they don't have the ability because they don't have the brain parts that allows production of language.
Right. And I remember Erica in that debate you had with her, she was trying to line up the Australopithecines, different brain sizes to try to say, oh, well, you can see they're growing over time and that sort of thing. What would you say to that assessment? I know that we're not really talking about Australopithecines today, but just kind of give your impression of the idea of assuming her assumption that the different brain sizes from the different Australopithecines means that it must be evolving into the size that we have today.
Yeah, the problem is she takes different fossils and tries to put a progression on those fossils. And that's a problem because you have one fossil with certain traits, you have another fossil with other traits, and it could be they're just different. And she tries to say, well, this is becoming that. This trait is not there. This fossil, the trait is there. And so it evolved that. And there's a problem in that because you can't say that this fossil evolved into the creature which this other fossil represents. That's a problem. All you can say is that we've got one fossil here with this trait. We've got another fossil over here with another trait. You can't tie that indeed one evolved into the other. All you can say for sure is the traits are different. And this is where the evolution glasses come in. Once you have those evolution glasses, you see this trait becoming some other trait. I think the best example of that is where parts of the jawbone evolved into the bones of the ear so they could hear. And this is, again, you take an animal with a certain jawbone design, and then you take another animal with another jawbone design, and yet that animal does have the three bones, the malleus, incus, and the stapes to facilitate hearing. So you make the assumption that this bone evolved into the malleus, the incus, and the stapes, and they've done that a lot, evolutionists have. And you can't logically do that. You can't say that this bone evolved into this other bone. All you can say is in this creature, you have this structure, and this other creature, you have some other structure. And so the most you can say is that there are differences. Of course, that's not the problem, is differences. It's not the problem that evolutionists have. The problem they have is that they assume that one set of changes evolved into the other set. And that is a problem, a heuristic, severely heuristic problem that they have in trying to do this. Now, of course, they see the world through the evolution glasses, and they see these changes. And so they're from their mind, they must have occurred. But at face value, all you can do is say they're differences. You can't say that one structure evolved into another structure.
Right.
Although you
And say
can
again.
structure.
Yeah. And with that also, they're missing those transitional fossils that would actually make that link. All they basically do is they have this whole fossil here, and this whole fossil here, and then they say, oh, well, this is a different size from this, and then they line it up to say, well, it must have evolved, to us. It's like, no, there probably was variation there. But that's all it is variation. You have to be able, like you said, you have to link them, and you don't have, and she likes that link. All right. I want to talk
Well,
about
she's looking for that link.
right, the inner ear. Are there differences between the inner ear between humans and um humans and apes, the inner ear, are there differences? Because obviously the inner ear helps with our balance. And that obviously is something that helps us walk upright, that we're able to maintain balance. Are there differences between our inner ear versus the ape inner ear? I mean, are there like you mentioned, I think you talked about the skeletal differences and stuff between humans and chimps, and obviously, but what is your assessment on the inner ear there?
Oh, yeah, there has to be differences because we walk normally upright, and the design of the inner ear has to be that this is the normal way. Inner ear design has to be to trigger a problem if they don't walk up, if they don't walk on all fours. And so we're bipedal. And so therefore the design of the bony structures in the ear ossicles has to be such where it's different, it responds in different ways. I suppose you could, by the ear itself, evaluate whether that they walked upright if you have preserve these bones. Of course, the ear ossicles are the smallest bones in the body, and therefore, because they are very, very small, they're not preserved very well in the fossil record. So therefore, it's hard to make comparisons. But the ear, for balance especially, has to be different. I'm sure anybody has looked into that because the ear system, which determines balance, is pretty obvious, and the other differences are not quite obvious. I'm not sure if we had a cochlea and if we could compare a human and an ape. Probably there are differences in sounds you can hear, so that would be one difference. Like 20 to 20,000 is the range that we normally hear, and my guess is probably apes are not quite that range. It's a different range, but I'm not sure. That's an interesting question, though. But I'm not sure that people have looked into that very much. Probably they have, but it's not a major area. That
In
they're
your
hearing is probably different.
in your presentation, you mentioned that one of the unsolved mysteries that evolution is faced with is evolving the different sexes, the different genders. And could you be able to describe the differences reproductively between humans and apes? Obviously, there's going to be differences in our ability to reproduce. We both can reproduce, of course, but we obviously wouldn't be able to reproduce with each other. Could you describe those differences?
Well, probably the main difference that they look at, that researchers in this area look at, is that humans are able to sexually reproduce pretty much most of our lives, our adult lives, whereas so many animals are only sexually responsive during a very short period. Like I was watching a film the other day on, I think it was on lions, and lions are only sexually receptive very short period of time. And they say it's called in heat, and therefore they're only receptive during very short periods of time, where that's not true at all with humans. So that'd be the biggest difference between reproduction. That lions basically out of their lifetime, there's only a matter of weeks at best that they are able to reproduce, able to respond to sexual stimuli from the other, in this case, the male or the female. And so therefore that would be a difference. Where humans, it's not true at all.
Can you describe the
So that'd be a
differences
big
between
difference how they respond.
Can you describe the differences between humans and apes on their rib cage? I know that we've talked about this before on my channel when we were doing the debate review. Could you kind of describe the differences there between the way their rib cage is designed versus the way our rib cage is designed?
Oh yeah, that's another fairly big difference because when we walk upright, the weight of the organs are in a different part of the body than an animal. When an animal walks on all fours, the weight of the organs are on the ribs more than our case. So it is on the ribs in case of humans, but much more so in the case of animals that walk on all fours. And therefore, that would be a clear difference that you would determine. And part of it's the strength, and I'm not sure the number of ribs. I'm not sure whether primates have more or less. Probably depends on the primate, but there probably is a difference in the number of ribs on a primate and the strength and the size. And therefore, that would be an easy difference to determine. Something I really haven't thought about, so that's interesting to think about it.
Um, what would be the when you look at the fossil records and you see apes and chimps in the fossil records or apes in general in the fossil records, are there differences also between humans, between humans of the past versus humans of the or versus apes of the past? Some differences there in terms of the you know anatomical differences.
Probably the main differences you find is due to what we do, what kind of work we do. For most of history, most labor was carried out by people. People did move things and planted crops and so on. Whereas recently, more and more of this is being done by machines, and therefore men are and women are far weaker today than they were in the past. Muscles, of course, would be part of it, but also the muscle movement on bones causes the bones to be stronger. And so therefore the bones would be more robust among our ancestors until fairly recently. When I was born in 1946, we had still a lot of work was done by manual labor. But nowadays, boy, it's amazing how much is done by machines. And like mowing the lawn, I used to have to mow the lawn. We had a hand mower. I didn't know anybody who had a power mower. It just wasn't around. So I had to mow the lawn by hand, and that's with those push mowers that's a lot of work. And now I don't know anybody that has a push mower. All my neighbors have power lawnmowers, and some now more and more have ride-on lawnmowers. And so we don't have to push that thing, which was hard to push. And therefore, the strength today compared to yesterday is quite different because, and I see this as a problem. When I was younger, we used to go shopping. We'd have to walk a lot, go to the mall, have to walk a lot. Now, so much of my shopping is done on Amazon. I sit in my computer, I order something, it's here the next day or 2 days later. Just had something come today that I ordered a couple days ago. And so my guess is that we'll have less and less activity outside shopping and more activity on our computers. We use our computers to look for things and buy things. And it's easier in many ways. I don't have to walk around in a store looking for something. And I can just do a search on Amazon and find it. And that's why I think they've done so well.
Yeah, my mom used to own or when she was alive, she owned a push mower because she always liked to exercise. My stepdad still uses the push mower to mow the yard, but I guess they just kind of like the exercise it gives them. Um, but yeah, I actually come from a day that I actually remember push mowers and the ride mowers.
Yeah, well,
All right,
yeah,
the
it's a lot of work.
right, the the teeth are the teeth of apes different from human teeth? What are the differences there? Do you know the dental structures? I don't know that if you're
The
familiar with.
main
Go ahead.
main difference is we have three different types of teeth. We have molars, we have premolars, you have incisors. We have three types of teeth, whereas I'm not sure in primates the major difference would be the canines they have, the because they're primates and they're meat eaters, and therefore they have the canines, which are important for meat eaters. And so therefore the main difference between me and my dog is obvious. It's they have these large canines which they use to eat meat. Of course, they don't use them much anymore. Our dog doesn't, but they're there. And we don't have that. We don't have any large canines that stick out. And so that's a huge difference. Although we have several types of teeth, which many animals don't have. They just have 15 or 10 or whatever teeth, and they're all pretty much the same. So not sure about that's something I guess I could look into, but not sure about many. My guess is that chimps would probably have some similarities, but they still have the canines, which we don't. And
Right.
meat eaters, carnivores would have different set of teeth on the average, I think, than herbivores. So that'd be a difference.
What about the facial features of the ape? The way they obviously there's if you look at an ape's face, it's very different from the way ours is structured. And so are these just slight differences? Are these fundamentally differences between us and apes? Like you look at an ape and you can distinguish that this is an ape by those features. I know that they have no whites. I remember that they have no whites of their eyes because a lot of times museums try to make Lucy look more human by making, the Lucy look like it has whites in its eyes instead of dark. So
Yeah. A big
what did
difference
you
is
say?
the muscle structure. A big difference is the muscle structure that we can produce lot more facial differences with our muscle structure. We can produce many we can communicate very effectively by our produce a pretty big smile, but they can't produce the variations that we can. Again, we can, as they say, they can read you by your face. I have 2 or 3 books on how to read personality on the basis of the face, and they claim that they can read your personality and a lot about you judging by the muscle structure you have. And so this is one way of communicating information to others by the face, where chimps can't do that. They get pretty big smiles, and I guess they get a few frowns and so on, but their ability to communicate via the face muscles is far less. Again, that's because we have a lot more facial muscles. It's designed a lot differently than it is in chimps. So evolving from chimps to humans, or our chimp common ancestor, I should say, to humans, there would have to be a lot of changes in the facial muscles,
Some people say that there's
which is
that because they claim that we're so genetically similar.
interesting.
Some people claim that we're so genetically similar to chimps that there would be very little anatomical differences. How would you respond to that claim?
Well, there are, of course, a lot of anatomical similarities, but there are also a lot of differences. A lot of differences are minor. At least we would judge them as minor compared to gross differences. And they're partially because their whole lifestyle is very different from us. And you talked about balance earlier. I think that probably one difference would be balance. I'm not sure we can swing from tree to tree as apes can. And apes, if you've noticed, chimps are really good. They can judge how far a limb on another tree is, and they can jump, and usually, not always, but usually they can grab onto that limb and end up moving around that tree. So there's no way that humans can move around the trees nearly as effectively as, of course, chimps can. And so they certainly have some advantages that we have, but we certainly can't. I mean, some men, I guess, if you watch the Tarzan movies, some men can develop those skills that they can move around better on trees than other men. But on the other hand, there's still a huge difference. I would guess in a human chasing a chimp, chimps will get away pretty effectively, given their arboreal lifestyle, their life in the trees.
All right, I
But
was
just noticing
wondering.
how
Oh, go ahead.
notice how they run around in trees like we run around in the grass. And they're really good. And I mean, they can start at the bottom and end up at the top. And you
And they can
wonder how they can do that so effectively.
they can skip
Of course, they
trees
have less
too.
weight, and they can jump from one tree to another.
All right, I was wondering what your thoughts on the new genetic study, which overturned the 96% to 99% number by identifying 12.5% to 26.3% differences between humans and apes. Evolutionists attempting to damage control are trying to minimize this impact of these results by claiming that this is biologically insignificant. What are your thoughts on this, on that study? I don't know how familiar you are with that study, or at least you know something about it, or what?
Yeah, I'm aware of it. Yeah, the one in Nature was published in Nature a few months ago. But yeah, of course, no matter what evidence we find that shows indeed human evolution is not very likely, they're going to come up with rational explanations that they feel are rational to try to explain the difference. And so they'll say, well, yeah, it's 85% similarity. That's a lot of similarity. And this 15% is minor. It doesn't really make a lot of difference. And so therefore they could evolve easily from our chimp ancestor to humans by making some fairly small changes. And so, yeah, they're going to attempt to minimize this difference. But to some degree, at least a few people I know, the evolution realize that we've got a problem here. We really can't defend our worldview very well. So we need to come up with a way to bridge these concerns that the creationists bring up. And so I don't think the evidence will affect them much. The example I used earlier of the backward retina, I mean, that's been refuted 50 years ago. And we know that the retina has to function the way it is. It's not going to function the other way for many reasons. And therefore, to claim that the retina is backwards, and this is an example of poor design, is just irresponsible. And I find they use a lot of the same stuff over and over. Partially that's because my supposition is that evolutionists really don't read our literature much. They don't carefully follow what we're saying. And that's a problem. And some that do are trying to refute it. So the purpose of reading our literature is to try to find what's wrong with it. And so they focus on that. But my guess is not many scientists read very carefully at all what we've written. Part of it is when I was at the medical college, we had enough reading to do in the area that we were researching. We had on folate receptors, for example, is one area we looked at. You'd be amazed at how much literature is on the low common folate receptors. And you had to stay up to date in that area. And therefore, when you go home, you're not going to be inclined to sit down and read some creationist book or some book that supports the creation worldview. You focus on what your area is. You focus on what you're expert in, and you keep up with the list. Guesses from associated with colleagues is that most are really basically unaware of what we're saying. And they're creationists, they don't know what they're talking about, therefore I'm not going to bother with them. And therefore they, for many reasons, don't bother to read it. And so therefore, what we're saying about this area of the 98% to 85, 86%, what we're saying is that, yeah, this is significant, but I wonder how many evolutionists are really aware of it and really care. I would say most don't care. We evolve, end of story, period. What's the difference? So,
Right. Recently I had done a publicized my own model on the so-called heat problem, and I remember recently debating these critics, and I was very explicit, not just in my video but in the comments too, to them about what I meant and said, and they still kept on misrepresenting me constantly. It was almost like they weren't paying attention to my words or something. Um, uh, Going back to what you said on, see, I had a question that lost me. Oh yeah. Um, oh, I was wondering whether they were because I've got a mini series out called the Tompkins Controversy Revisited miniseries because of the new study that's coming out and responding to some of the videos that are being produced by Erica from Guts and Gibbon as well. Um, but I wonder the way she's arguing her position, whether or not if they're assuming, because a lot of the differences that are found between us and apes are found in the repetitive regions. And so I wonder if she's just thinking, oh, well, that's just junk DNA, and therefore it's not biologically relevant, functionally speaking. And um, if that is what they're saying that this is just junk, this just garbage results and that sort of thing, what would you say to someone who thinks that this is that most of our DNA is junk and is biologically non-functional?
yeah, since you mentioned that, I would say that's probably what they'll try to claim. Yeah, there's 15% difference, but this is mostly junk DNA, so it doesn't make any functional difference. So the 85% is what determines us and apes, and the 15% doesn't matter. So yeah, we're 15% different, but all that's irrelevant, so it doesn't really matter much. So that's probably what they'll claim. The what I think they'll find is, as they're finding now, is that that 15% does make a difference. And that 15% is very important. And as they sequence more and more genes and find the function for more and more genes, and even find a function for genes that don't code for protein, as they progress in that area, my guess is they're going to be able to find indeed that that is important and therefore reinforce what we conclude. I've often said that evolutionists themselves will disprove evolution. They will do it. And that is what we see going on, that evolutionists themselves are disproving evolution. And I think that's going to continue to happen. And I think eventually evolution will die because of the work of evolutionists. And so unfortunately, they don't rely very much on what we do. Although some, again, to refute it, look at it, but the purpose of looking at it is not to understand what we're saying, but the purpose of looking at it is to try to refute it. But I think it's going to get to a point like the progression. I think that's pretty well we've won. We've shown that that's not true. And so but they themselves have also, their own research, shown that the progression is not true, and it's irresponsible to use it because it's not true. So they themselves are proving indeed that our worldview is correct. Although they wouldn't acknowledge our worldview, they say, yeah, we acknowledge what we're saying, we're doing, but they're not going to say, well, I think I'll become a creationist. That's not. Evolution is too heavily ingrained in their worldview.
And my next question is, do you think that evolutionists, are there any anatomical differences that you would say evolutionists overlook or maybe even downplay, minimize, like, oh, well, yes, true. I know that we talked about the rib cage. I know that's one of them that a lot of times I've seen evolutionists try to minimize. Oh, well, that's not really that important. And it actually is, and that sort of thing. But would you say that there are other types of differences that that they'll try to minimize, or they'll overlook, or that sort of thing, or downplay, um, uh, that there are between humans and apes? They're more significant than what they're trying to argue for.
Well, they'll downplay it, or they'll say, yeah, we know there's a huge difference between language. No question. We accept that the language ability is enormously different. And there are a lot of anatomical differences which allow for that difference we see. So they'll say, yeah, that's true. The brain, we know the consciousness, we know that these are different, but so what? So they'll acknowledge the differences, but they'll say the differences are there, but that doesn't really prove your point. That doesn't prove we were created. It proves that the evolution has evolved us even further along the line toward humans than it has other primates. And so they'll say, yes, the differences are there, but it doesn't matter. Or they'll acknowledge the differences. Or they'll say, yeah, these are differences. We need to try to explain how and why. We need to understand why humans are conscious in ways that animals are not. Why? What caused that? I have whole books called The Origin of Consciousness, and they're trying to explain how we ended up with the conscious mind that we have. And therefore they say that, well, yeah, there's differences there, but that doesn't mean it can't evolve. We just have evolved more in that area. And so to find differences, I don't think it's it's hard to say what will convince the evolutionists of their worldview. It seems like as each argument is shot down, that they'll get to a point where they realize that we don't have an argument. But of course, many, when I worked at the medical school, they weren't concerned about this. They were concerned about curing cancer. They were concerned about understanding folate receptors, understanding mutations in P53, and they were concerned about a lot of things, but evolution wasn't by and large in their mind. They didn't care. It didn't really care. It didn't matter what you believed. And whereas in a non-medical setting, in a university that has a lot of research, doing a lot of research in other areas, then they are concerned, but not,
Right.
I find, not in a medical school.
We're fixing to come to the end on our Are We Apes series, on the series I have with Are We Apes, which is this an episode in that. And I was just curious because I know that evolutionists refer to human beings as apes, and they call us that. And I've heard Erica actually say that we have all of the synapomorphies, uh, that share between humans and apes. So essentially, it's like we define apes this way, and she's claiming that we have these kinds of characteristics that an ape has that defines an ape as an ape. Um, uh, what would you say to that?
Well, that's how she defines things, but I think even on Dark Alley, I don't have much of problem distinguishing a chimp from a person. I mean, it takes a few minutes by appearance, by voice, by locomotion, by so many ways we can distinguish the differences very clearly. So there are huge differences, and she's trying to minimize that. But I don't know a lot of her background, but I think she was a creationist and believed in the creation worldview. And then she went to college, and I guess a Christian college actually, and they convinced her of evolution. And now she's seems to want to spend her life to hurt those people that or those ideas that she used to believe in. So I think that's why she's so motivated. Certainly a bright person, works hard, but I wonder. It's kind of like you leave a certain country and then you go into another country and you bash the country you left. So I think to some degree, she's trying to convince herself of rejection of the creation worldview and accepting the evolutionary worldview. She's not so much trying to convince you and me, but trying to convince herself. And I think that's a strong motivation she has to. I don't know how she was hurt, but she was evidently pretty hurt when she realized that the creation worldview was not true, as they taught at the college, or the Christian college where she went to.
Right.
And this is
And
not unusual. I know a number of people who went to Christian colleges and accepted the evolutionary worldview. And often, though, they'll accept the evolutionary worldview, but this is how God created us. So they use that as God's means of creation. So they still accept evolution, but they're still, I think, Gutsy and others they're angry that they accepted a worldview which now they don't accept anymore. And so it's hard to, psychology of these people is interesting.
I like the fact
And they
that
often say,
I was going to say I like the fact that I went to Liberty University. They're very conservative, so they don't believe in evolution. Their official position is young Earth creationism. So I like that fact. But
yeah, well,
go ahead.
about 12 colleges that their official position is the creation worldview. And Master College is one, Cedarville University is another, Loma Linda University is another. So there are few out there that accept the creation worldview.
In Liberty University.
Probably, though, the scientists work around the evolution worldview like Baylor. Baylor, they work around the evolution worldview and they become convinced. Baylor used to be a strong creation supporting college. Taylor University, not too far from here, they used to be very strong in supporting the creation worldview, but they've rejected that now. They teach the evolutionary worldview. There's a friend of mine who knows the president of Taylor University, and he's a creationist, and he said maybe Bergman can come by and talk to the faculty there at that university. And the faculty said, he can come by, but we're not going to go hear him. So if he comes by, you're not going to be in any of the science faculty. We don't want to hear what Bergman has to say because he's wrong. We're Christians. It's a Christian college. We stress the Christian worldview. But on the other hand, we accept the evolutionary worldview because that's fact. It's true. And so therefore, they're not interested in. And I thought it'd be interesting for me and them to have me on campus and talk to the biology faculty. I think we could have some good conversations. But even the president, he says, I'll invite you. You can come on campus, but the biology faculty, they don't want to hear what you have to say. And so therefore,
But what would you say to the claiming of taxonomical identification of us as apes, where they just kind of like label us that way? Would you say that is just like it's man-made it's like a man-made decision. It's based on their evolutionary assumptions about us
Well, yeah, to
being
say we're
related to
primates is
apes.
man-made. I mean, certain they have certain criteria they use, and we fit in that criteria. Linnaeus, in his taxonomy evaluations, that's what he classified us. So, body-wise, yeah, we would fit in one category certainly far more effectively than some other category. And so therefore that's understandable why they do that. But it's pretty well known that we are in a category by ourselves. Pretty well acknowledged that, yeah, we have maybe primate bodies and we have similarities between us and primates, but on the other hand, we're in a whole separate category. We have humans and then we have animals. And no one denies that there are two categories. We got humans and we got all the other critters, which are either animals or insects or fish or plants. So you were in a separate category. That's pretty obvious. But I guess when you're classifying things, probably from a body standpoint, we'd fit best in the primate category. Period.
All right. I got one final question for you, Jerry. Um, Evolutionists claim we are not only related to apes and evolved from an ape-like ancestor, but that we are apes. What is your conclusion concerning all of this data? Are we apes? What is your assessment? Would you say no, we're not apes. We're very different from apes. Apes is a literally a different animal with a different color. So, but what would be
Yeah,
your assessment
I
after
would
research
agree. We
all this?
are not apes. We're different than apes. But the terminology is interesting because as I did this book on whales, the animal that whales evolved from is basically a dog. It's Pakicetus. It has a nice name, but it's basically a dog. Looks like a dog. And so they call it a whale, even though it's a dog. From our standpoint, it's a dog, even though they call it a whale. So I was mentioning this to my wife to say, technically, our dog is technically a whale because he's like the other dog, he's technically evolving into a whale. And therefore, like Pakicetus is a dog, but he's evolving into a whale. So therefore, you call him a whale, even though he's not. So to say our dog is a whale because the dog in the past evolved into a whale is ludicrous. And of course, but nonetheless, it's foolish to call this animal a dog when it's start again. It's foolish to call him a whale when he's really basically a dog, even though they gave him the name Pakicetus.
Right.
So it's the same thing.
I I sometimes ask a evolutionist question like, what are we evolving into? Because I mean, it's one thing to point to animals of the past and try to find similarities, but what exactly are we evolving into exactly? Because according to
Well,
them,
that's
we're
a
still evolving.
yeah. They would say we're hey, evolution is slow, and yeah, 2 million years from now we may be something very different. So yeah, we're evolving, but we're evolving very slowly, and a long time from now we may have evolved into somebody very different, something very different. But it's just so slow that therefore you have to look at thousands or many thousands of years to look at evolution. If you look at go back 2,000 years or 10,000 years and look at an animal, yeah, not seem to be evolving, but of course we know today evolution would say that it has evolved into something else. So yeah, they would. I think that kind of question frustrates them and they get angry. They tend to say, "Well, that's not." But that's right.
Right.
Or they might say that we evolved at the peak. We cannot change in any way to be more effective. We've evolved to a certain point where no evolution beyond this point is possible because there's no way we can change to be more reproductive, more effective in our life. So they probably say, yeah, we've evolved, we're at the pinnacle of our evolution, period.
Wow, Jerry. Thank you very much for your
Okay.
presentation. Thanks for the Q&A. That was awesome, awesome answers. I appreciate you giving us your time here today. Do you have any final thoughts to leave everybody with?
Now, as I study this issue more and more, I can see it's really irrational, like so many things are irrational. And so, likewise, the same thing is true with evolution. It's really, if you think about it, foolish to believe that evolution actually can occur, that primates, that our chimp ancestor could evolve into people. It's foolish to believe that because it's so contrary to the evidence. But yet it's widely believed in the world of science. And so therefore what we have is not just irrationality, but we have delusionalism, that the scientific community is delusional in accepting the evolutionary worldview, which is overwhelmingly not true. And as time goes by, evolutionists themselves are helping convince, uh, helping to basically disprove evolution and prove creation worldview. Evolution is delusional. It's mass delusion. They believe something that's just overwhelmingly not true.
Right. I like it, the fact that we live in a day and age where all of these different studies are coming out and they're being written by evolutionists, and they're finding out that things are not quite exactly what they thought it was, what they expected, or what they predicted. And especially in the areas like genetics and Y chromosome, and it's just coming out in a very different picture than what they expected if the evolutionary worldview was true. So I
That's
really
true.
enjoy that. I really enjoy seeing all of this modern stuff come out, and it's like that they were expecting one thing, and then they got something completely different. And it's like, oh no, we didn't expect this, we didn't predict this, we this shouldn't be the case, but it is. But anyway,
Yeah.
thank you again, Jerry. I appreciate it as always. Thank you for coming on my channel. Um, but I guess we reached the end of our discussion. And I hope you are doing well, and I hope you continue to do well, and God bless you in your work you're doing, whatever you're working on right now, and whatever you work on in the future. And I guess
Well, thank you.
we'll see you later then. God bless.
Yeah, just let me know and be glad to do another show with you. I have
Thank
60 PowerPoints, so I have a lot of topics I can cover.
Right.
I need to send you all the topics that I've had PowerPoints on. And so yeah, when I'll do that when you sign
Yeah.
off, if I don't do it, remind me and I'll send it to you and we can cover some other different areas.
All right.
So okay,
I'm going to send you the link to the paper that I mentioned earlier on the Y chromosome. You'll find that
oh,
interesting. If you go to the
please
chart,
do. Yeah.
if you go to the chart 1B and click on it, so it enlarges it, you can actually see where the percentage, and it actually lines up with created kinds. Seriously, it lines up with created kinds very well. Like bonobo and chimpanzees are the same created kind, no doubt. And the two species of orangutan are the same created kind. But then when you get to the other great apes that do not interbreed with one another, and you suddenly realize there's a low percent similarity between them. And so it lines up perfectly with the created kind model. So that's one of the things that I really like about that study. But hopefully you'll find it
Okay.
interesting
Well,
too.
I'll look at that.
Yeah, at
Oh,
26%
I will.
similarity between humans and chimps. So that's really, really low. Um, but anyway, I'll talk to you later, and thank you again. I appreciate your time as always. God bless.
Okay. Glad to be on here. Take care.
Thank you for watching Apologetics 101. I appreciate it. Don't forget to like the video, subscribe to my channel, and hit that notification bell. Share this content on your community pages on social media. Let other people be aware of it. And this is only part one of two videos I'm actually doing for the last episode of the Are We Apes series, because I'm going to actually be doing a second interview also on the differences, anatomical differences between humans and apes with Brian Thomas. And I have that interview scheduled for next week. Actually, I checked it and I have it scheduled for next week, so I can't wait for that. And so that'll be the second one, and that will end our Are We Apes series. But it'll be next week, and or at least the interview will be next week. And that way I can sit there and finally end the Are We Apes series. And I'm also thinking about one of the questions to be on the alleged common synapomorphies that are often claimed by evolutionists. So that's something I've been doing some work into. It's a cladistic terminology that's used by evolutionists. It's very circular, but in any given case, um, I'll get into that later. But anyway, thank you for watching again. I appreciate it, and God bless.